Hello everyone, in this video we'll be focusing on migrating 3-tier application to Kubernetes. We'll start with the project architecture, then move forward with a demo on how to create the Docker file for the front-end and the backend, how to optimize your Docker images for production, create Docker Compose file to launch all the containers and make sure the connection between them. Then we'll create Kubernetes manifest files. Last but not least, we will use Azure DevOps to build and push Docker image to Azure Container Registry, Argo CD to continuously deploy our application on Azure Kubernetes Service. The developer will start coding on Visual Studio Code, then commit his code to GitHub and it will trigger Azure DevOps. Then Azure DevOps will build and push the Docker image to ACR. So we'll make modification to the YAML files and Argo CD will sync the changes to our AKS cluster. So I'm going to explain the structure of our GitHub repository. So we'll have the src folder which contain the code for the front end with the Docker file and the backend with the Docker file and everything else. Terraform folder will contain the Terraform code to create the ACR and AKS cluster and linking them together. Pipeline will have the Azure DevOps pipeline we will be using. The documentation is a simple website that documents the whole process with the code and step by step. Docker Compose file is to launch all the containers. Argo CD folder will have the commands to install Argo CD on AKS. So let's start with the best practice is run the application locally. So we need to first install the dependencies using npm install for the front end and the back end. Then you need to look for package.json. Both applications are built on top of JavaScript, so use npm for both. So you can look for, this is the backend, so to start the application you can use npm run start or start dev. For the front end we'll be using npm run npm run start. So let's go here. So it's still installing the dependencies here. So in the backend is finished, so we're gonna run npm start dev. Front end still installing. Okay, so I forgot to stop the Docker images. Docker. 1 second. So the front end is starting. So npm run start. The backend npm run start dev. So and to start MongoDB I'm using brew. So brew services start MongoDB. So now we're gonna go back to our local browser, localhost. So let's try. The application works. Yes, it works. So we added this email and last name and first name and age to our MongoDB database. So the best practice and the easiest way to do all of this is to containerize or using Docker image for each container, for each component, sorry, which makes the integration very easy. So using using database as Docker container is not very recommended, but in our case we can do so. So I'm going to stop the service, so the application won't start. So I'm going and nothing. Now I'm going to run the Docker container for it. So let's go here. So this is the Docker compose. So I'm going to comment the frontend and the backend. We'll go back to it later on. So this is the name of the container. So when you're addressing the database, you will use if you're using Docker Compose, this name, the service name. If you're just using Docker Run, the Docker name is where the containers can talk with each other. So in our case is Docker Compose. So the container name is MongoDB, the image is Mongo 6 Jammy, the environment are the initial database. Instead of using brew, I created the database beforehand. I'm using volumes to persist the data. The port are 27017, and networks is not very necessary to have the static IP, but it's not very important to talk about. So let's go to our Azure repository. We're gonna use docker-compose app-d. So this one will only launch the MongoDB. Let's go back to our application and refresh it, and now it's good to go. So common problems are always verify the name of the container if you're using Docker Run, the name of the service, and the port. So in this case, so the backend will reach the MongoDB database via localhost. So because we link the both port, if you change, for example, this port to 3030, for example, so we need to go back to the environment variables in the backend and change it here. Oh, 3030 or something. Okay. So when we are switching the backend to Docker, so we can't use localhost because it will ping itself. So we're gonna comment this one and comment, and we leave the MongoDB name as the URL is for the service. This is the port for the backend. We'll leave it at 3700. Now we're gonna talk about the Docker file. So in this Docker file, we'll use a very small Alpine image. So if you use Node 16 without Alpine, it will be a kind of big Docker image. So in production, it is not very recommended. It's not recommended at all to use big images. So this in the backend, we'll only use one stage instead multi-stage in frontend. We'll talk about it later on. So we're gonna copy the package.json. You can copy also the log for the version, which is not, in our case, it will not affect anything. In application, it might. We're gonna run npm install the packages, copy the rest of the code, expose the port 3700, and run the command npm run start dev when the container is created. So let's go back to Docker Compose. I'm gonna uncomment this one. So those are for the environment variables. The network, it's now this, it will be the same as MongoDB. The container name is backend. You can, if you push your Docker image to GitHub, you can use image, and else now we're gonna try to build the application again using the build option, context, and Dockerfile. The port is 3737, and it will be depends on MongoDB. So the backend won't start unless the database already started. So in this application, it doesn't matter, but some applications will not work if the backend start, then it will not define MongoDB, and it will not retry, for example, a couple of seconds, couple of minutes. So either you hard code it or add depends on. So now we'll go to database. We're gonna stop it and update the Docker Compose. So Docker Compose build first to build the application. So it finished very quickly because I already built it. But if it's the first time, it will a couple of times. So now we're gonna use docker dash compose app dash d. Now we're gonna start the backend. Now let's go back to our application and refresh. So it's still working just fine. So the front end is connected with the backend. Let's go back here. What is it? So something to notice is inside the package.json we have the proxy. The proxy is the point where it will, when sending a request, will obviously point to the backend, so it's localhost. But when you are Dockerizing the application, it doesn't matter. So, however, using proxy is one thing and using environment variable is another thing. So in this application, environment variables were not implemented, only proxy. So when you push your front end to production, this one will not work even if you put the right URL. So I will talk later on a quick fix using nginx and config files. So now I'm going to Dockerize the application using this Docker file. So this Docker file will use as a base node 18 Alpine, the working directory /app. I'm gonna copy the package.json, install the packages, and copy the rest of the code. Okay, so if you are using this as development purposes, not production, and comment export port 3000 and the command for run npm run start. Else, if you are using for production, like in our case, gonna run the command run npm run build to generate this folder which contains the static files, etc. Then the second stage is for production, so we'll use a very small nginx Alpine image. The working directory is the directory of nginx where we're gonna put the files. We're gonna copy from the builder, which is this Docker stage, and copy what's inside the folder build and put it inside HTML. I'm gonna remove the config file, the folder inside nginx, and copy this config file. So this config file will make the application listen on port 3000. You can change it to 80, etc. It's up to your configuration. So the file, it will route this folder, and the index is index.html. Anyway, and for reverse proxy, so the problem we talked earlier, because proxy now is looking for backend, so we cannot use it and show you guys. So I'm going to comment it right now. So I'm going to delete because I don't know, for some reason I can't comment using the command. Okay, so now we're gonna build, use docker-compose app-build. I forgot one last thing. So we're gonna expose port 3000. I can use port 80, it doesn't matter for our case, and the command to start nginx. So let's go back to launching the I'm going to use docker build, docker-compose build. Will take a bit of time, but anyway. So I change the okay. Now docker compose app-d gonna launch the new container. Oh, by the way, I forgot to start this one. Stop the front end. So let's start it again. Okay, sorry, I forgot. So I need to stop the front end and comment the front end. So the front end is basically the same. This one environment, I was experimenting with environment variables, but the application didn't work with this, so I'm not gonna use it. So you can use the container Docker image if you pushed it to the ACR of ACR, Azure Container Registry. Else, in our case, we're gonna build it right now. So the context where the file is, and the context is the Docker file. So, and the front end will depend on the backend, so it will not start unless the backend is started, etc. So I'm gonna save everything. Docker compose build first. There is a problem. So line 23. Let's. Okay, I don't know what happened. So Docker build. We're gonna build the new Docker image. Okay, now everything is ready. Gonna launch the last container. And refresh. So as you can see, there is a problem with the connection. Let's see. Let's verify the proxy first. What is the proxy? Proxy. So let's change it to backend and see. Or actually, this is not the problem. We'll leave it. So now we're gonna go to the inside the container. Docker exec interactive frontend dash. So if you want to make some changes very quickly, just enter inside the container. Now gonna go to this path and sv install good. So edit this code. So config file. Just copy it. Right quit and let's see. So another way to verify, going to inspect network. So let's say see so it's looking at HTTP localhost to port 3000. So the proxy is not working actually. So it will directly port to itself, port 3000. So you need to implement environment variables because proxy will not work in this type of scenario when we're building the application and using Nginx. So with this code, 99% will work because I tested it. So it will redirect this API users to this URL, and the frontend container knows this backend container. So now we're gonna rebuild the application. Docker-compose build. So the build will not start all over again. I'm going to add the conf.d and build it again. So it will cache most of the site from npm install, etc. Okay, never mind. So I'm gonna remove it and let it build from 0. And let's see. I forgot. It will not start from npm install because after installing the packages, we will copy everything. So it will finish around how much? What is it? npm build. Nope. Wait a second. It's already finished. So docker-compose up-g. So it will recreate the Docker image, refresh everything, and here we go. So this problem is because proxy first. So an argument is why it's pointing at localhost. No, if you look here, where is it? Users. Earlier the port is 3000, so it's itself. So it's a problem, but so using Nginx we can route if the URL is localhost 3000 API users to not find it. So what you can do is, what is the frontend source component? Not remembering very well. One sec. This one. Okay, so here again we need to modify it so it will take an environment variable for the URL. So in this application, the developer who coded it went with proxy instead of environment variables for some reason. But proxies will not work if you build the application, and for npm start it will 100% will work. So yeah. So now I'm gonna talk about Kubernetes manifest files. So for Kubernetes manifest files, the easiest nowadays is you can give ChatGPT the Docker compose file and tell him to migrate it to Kubernetes the best way. So it's very simple, to take maybe 2 minutes. Of course, you need to verify a lot of stuff, the environments, you need to read it and make sure. So we're gonna create the deployment for our backend and the service. It's report 3000 for both. It's 3700 sorry for both. To simplify it, you can choose different IPs for the port on the service, but here in the front end it will affect it. So when you for the nginx, so it will listen, it will redirect the traffic to port 3700. So leave it at simple. For the front end, same front end and back end, so you can specify a number of replicas, etc. So this is the name of the container. The image will pull it from Azure Container Registry. I will show you how in a couple of seconds. And for MongoDB, it's straightforward, the service database, but we added the persistent volume claim and integrated some volumes. So the MongoDB will persist data. So it's if it crashes, it will get back with the old data, else it will lose all the users. So what now? I'm gonna create the Kubernetes cluster. So we're gonna go to the Terraform code, gonna type in Terraform in it to install the dependencies and stuff. Then Terraform apply. So I will show you the code while it's running. For Terraform, we enter the root module, parent module, and parent module, and the child module is to create a resource group and the Azure Container Registry. So the specification, this is the location, which is ECOS, resource group name, so they are all together. This is the DNS prefix and the name of the Azure Kubernetes cluster. We use one simple VM for our case, add some tag and identity, and this one, Azure RAM role assignment, will link the Kubernetes cluster with the container registry. So now we're gonna type in yes. The process will take around 3 to 4 minutes, but the ACR will not take that much time to begin with. So now let's go back to Azure. So I'm using the student trial for this demo. So let's go to your Azure DevOps organization. You can create one. It's very simple. Just follow the steps, and yeah. So we can create a new organization. So we can do that. Continue and stop. So let's go to my organization. So you can create your organization like I showed you. Choose the project. Now the container. Okay, so the ACR is completed. Okay, good. Now let's go to home and Azure Container Registry. So this is the container registry we created. Anyway, so let's go to the pipeline. So you need to link your GitHub repository. So it's very simple. Go to pipeline. You can create a new pipeline and specify the code. So I put my code in directly in Azure, but you can use GitHub, which is the pipeline I'm using now. Click on here, select the pipeline. So it will ask you to it will redirect you to GitHub and give it access. I already did so, and it's not that big of a deal. So go pipeline, Azure DevOps, this is my pipeline, so let's see it. So in this pipeline we will only build the Docker image and push it to ACR. Oh, it's empty here. Anyway, we have the code in, you have the code here, pipeline, build and push to Azure. So the code is straightforward. So we're gonna have this stage for build and push Docker image, this display name. So we have two jobs, build and push frontend and build and push backend. So we're gonna push the Docker image to ACR. The repository name is frontend and the command is build and push, and this is the where this is the Docker file, and this is where the build will happen. This is the tag. I'm gonna push it to name it production, just like in our Kubernetes manifest files, and this one to production. So you can use Docker Hub. This is the code for Docker Hub, and comment it and change the container registry and the repository alongside with tags. So just copy this pipeline, copy it here, sorry. Okay, so now we're gonna go to, I'm gonna save it. When I save it, it will start the never mind. Okay, so I'm gonna save the build, so it will be triggered. So we're gonna stop it right now, cancel, and let's delete it all together. Anyway, now go to project settings. Where is it? Service connections. To configure this is the ACR, so I'm going to delete it and create a new one and show you how to. New service connection, so it's for Docker registry. Next, so you can use Docker Hub or Azure Container Registry using the authentication method. So I have a problem with loading my subscriptions. It's no big deal, you can use others. So how? It's very straightforward. You go to access keys and enable admin user. Copy the container registry name. It's for ID. Login server is for the Docker ID, for the Docker registry. Of course, don't forget to use HTTPS. The Docker password is this one. I will change it after this course. Paste it, and the service connection called ACR, the same. You can change it to whatever you want. I'm going to finish all pipelines if I want. And yeah, so now we're going to pipelines again. This one. And I will run the pipeline. And run. The Azure Container, the Azure Kubernetes service cluster is ready. So we can get credentials while it's building the Docker image. And I'll use AZ AKS get credentials, resource group created screwed up, and the name of the cluster screwed up AKS. Oh, sorry. AZ AKS. Yes, for overriding code. Kubectl get pods, we'll have nothing. Okay, now while the building is still in progress, we're going to install Argo CD. So these are the commands. And create a namespace. Using this command, we'll deploy Argo CD in the Argo CD namespace. This command will get us the initial password for Argo CD. just wait until everything is deployed. Sorry, I forgot. We need to verify if the pods are running. So when the application and all of them are running, we can get the initial password. And so it is in the finished stages to push in the Docker image. One last pod to finish. Good. Now we get the initial password. Then we're gonna access the Argo CD service. Port forward service Argo CD. We specify the namespace. The port is 80 for the service, and gonna use 8099 for our localhost. Localhost 8099. Advanced. Proceed to localhost and save. The username is by default is admin, and the password that we got from the terminal. Now the building process is for Frontend is finished. So if I access the container registry, we have go to repositories and we'll find Frontend. So it's already deployed. We have only one for production. Let's verify. Anyway, so it's both are finished. Let's refresh the page. So front-end and back-end. Okay, good. Now we're gonna link our Argo CD with our GitHub. So we're gonna call the application CRUD. Project name, you can keep it to default. Sync will be automatic. You can keep it at manual. Self-heal. So the GitHub repository is this one. I provided the link for everything in the description. And the revision is, let's keep it to branch main, and the path is Kubernetes manifest. Class URL is this one, and namespace I'll keep it to default. Now we're gonna click on create Kubernetes manifest. So we'll verify the URL, the folder password. Okay, I forget to push S. Nope. Okay, I was writing the router money. No problem. So anyway, so now the folder is right, so it will start syncing. It's out of sync. Let's click on see everything. Let's go back here, kubectl get pods and watch, and here we go. So the application are running. So the good thing about Argo CD is when you make changes to the GitHub, around 3 minutes it will auto sync with the GitHub repository, not in every 1 second. So let's see. As you can see, it could pull the front-end image and the back-end image without any problem, because we gave the AKS cluster access to the ACR to our Azure Container Registry. Anyway, So for example, if we go to GitHub and repository 1, Kubernetes manifest files, backend, let's keep it to one replica, and frontend to one replica. So let's wait until it finishes creating the containers, and so now Argo CD will not catch on until I click on sync. I'm going to click on sync. It will do it in around 3 minutes probably. So we don't know it. So it's out of sync. It will start syncing the and it is terminated. It terminated the all the replicants, keeps one for each one. So thank you for watching, and I will see you in another course.